Hey everyone, welcome to my YouTube channel. So I'm here with another video on capacity planning, and today we are going to continue from where we left off in my previous video. In case if you have not seen, so I'll link it in the I button above. So please go and have a look at it and then continue with this video. So in this video, we are going to talk about how to design or how to capacity plan a tiny URL application. Okay, let's assume that you are going to develop a tiny URL application, and what all things that you have to estimate to make it account up and running in normal days and peak time and during the festive or some campaign times, etc. All right, so for that I have prepared my notes in the interest of time. Okay, so instead of me writing in the class, so I'll explain with what I have prepared, right? So in the previous video, if you have seen, so we have discussed about the capacity planning, what we have what is capacity planning, and what is all the parameters that we consider in the capacity planning, so which are nothing but the daily active users and requests per second, write per second, read per second, and read write ratio, bandwidth, uh, calculation, cache requirement, db requirement, and replication factor, etc. All right, so let us continue with our understanding of capacity planning to make it more deepen with the some use cases. We'll discuss a couple of more use cases, and in this video I'm talking about tiny URL use case. Okay, so for this use case, right, let me make some assumptions. Okay, so what are those assumptions that we are going to make? These assumptions will be making it when during our requirement gathering section. Okay, in the business requirement document or project requirement document, these assumptions will be, we are going to ask these questions to our business users or the stakeholders who are uh, coming up, who have decided to develop this application, and we are going to help them develop it. Okay, so in the business requirement document, we are going to capture these informations, like what are the daily active users, since they are going to come up with the business, so they know that what is their user base is going to be. Let us assume that we have 10 million daily users that are going to come to the tiny URL, meaning they are going to use the tiny URL that are circulated. They are going to hit that URL and then they are going to use it. Okay, and how many URLs that are going to be created? Let's say 100 million URLs that are going to be created per day. Okay, that means the writes number of your new URLs that are going to created per day are 100 million. Okay, then we have something called read versus write ratio. We have assumed that 100 into 100 is to 1, meaning the one write will have 100 reads. Okay, meaning if you have created one tiny URL, it's going to be used or hit by 100 users. Okay, 1 is to 100 we can say. All right, and then average original URL length. If I am a user who is, let's say I have my certification I have done, okay, and then that URL is bigger one, I want to put it in my resume, so I cannot keep full URL. So what I will do, I will go to tiny URL, give my new URL, and then it will give me the tiny URL. So that original URL length is assuming to be 500 bytes, and the tiny URL that it gives me after shortening is going to be 20 bytes. So these are my assumptions that I am going to capture in my PRD and PRD, and based on this we will do some calculations and come up with the estimations for our system, that what is it going to be my database size, how many servers that you have to do, how many replication factors that I have to consider, what is the bandwidth of my server or system should be during the normal days and the peak time, right? And what are my content delivery networks, where all I have to set up. Then what is my cache requirement, right? What should be the size of my cache system, so that I can serve my users with something called hot URLs, right? With a better latency, etc. All those things we will be deriving with these assumptions. Okay, if you change any of these numbers, right, from 10 million to 1 million or 100 million, 100 million to 1000 million, etc., even this read write ratio, so other calculations are going to be changed or impacted accordingly. All right, so let's see now, right? See what are these calculations that we have, and these terminologies we have discussed in the previous video. Okay, what is my estimated write RPS? How many systems or how many users are going to write into my system per second? Okay, so here we have assumed that 100 million users are going to be writing to my system per day, and this we have to convert it to seconds so that we can estimate it properly. All right, so what I am going to do, this 100 million URLs divided by number of seconds in per day, which is 86,400. How I got to this one? Of course, it is simple one, you might already know, which is 24 hours into 60 minutes. Each hour will have 60 minutes, and then each minute will have 60 seconds. So 86,400. And then we are going to have how much it comes? It comes 1157, which is approximately, I will take it as 1.2k writes per second to my TinyURL system. Okay, now for every calculations that we do, whether it is write or read, there is going to be peak. Okay, peak meaning during the campaign that you are running, festive season, or if there is any offer promotionals that are going on, you are going to expect that my traffic to my system is going to be more, right? During that, it's multiplied by 3 times. We assume it to be 3 times. Okay, so this 1.2, if we multiply by 3, we are going to get 3.6k writes per second. All right, this is my peak writes per second. Okay, similarly we are going to have a reads per second, how many users that are going to read. Okay, that means reading is how many users are going to use your system. Okay, so we have assumed that 100 million users are going to read. Okay, how? 1:100, right? If I'm going to have 100 million URLs created, I'm assuming that it is going to be 1:100. Okay, so that is what I'm going to do here. Okay, 100 million new URLs that are going to create, and then 1:100 is what that I'm going to consider, right? So it is going to be 100 into 100, million, you can say. It's in billions or something, right? So divided by 86,400, it comes to 115k reads per second, which I am going to approximate it to 116k reads per second, right? How many we have? We have 3.6k writes per second, and we are going to have 116k reads per second if you multiply it by 100 approximately. All right, and definitely peak is going to be 116 into 3, which is 348k, and approximately it is 315k reads per second in the peak time during the promotional time. All right, so this is going to be reading and writing, right? So now how many URLs that are created, how many each URL is being hit by how many times, that is what we estimated so far. And to those URLs that we are going to create, what is the size that we need, right? Based on this estimation, we are going to come up with our database and bandwidth or cache system, etc. All right, so let's assume that we assumed that our original URL is going to be 500 bytes here, right? Original URL is going to be 500 bytes, and each URL, when it is shortened, it's going to be 20 bytes, right? But if you see, if I'm creating one URL, let's say www.vmk etc.com. Okay, this URL, if I'm shorten it, going to be www.vmk.com. okay, so how does it know, that system know that this is the shortened form of the URL, it should refer to the longer form of a URL? So there has to be some metadata linked to it, right? So that metadata is going to be approximately 100 bytes. So what is there in the metadata? It will be like, what is the short URL, what is the longer URL, and which user is going to hit that URL, what is the server, what is the country, what is the IP, and what is the load number of requests to that URL, all those things which are required for your analysis, right, analytics purpose. All those things will be stored, and which is approximately for each URL it's going to be 100 bytes, assume that. So totally for one URL the total size that is required is 620 bytes. Okay, 500 plus 100 plus 20, and approximately I'm going to make it as 700 bytes for my calculation purpose. So per URL that you create, your system should be require 700 bytes of size, okay, storage. Now based on that, we know that daily we are getting 100 million URLs, new URLs that are going to created, and then each URL is going to be of 720 bytes, so which is equivalent to 70 GB per day. All right. Now similarly, since we know per day, it's easy to calculate yearly storage, which is nothing but 700 GB into 365 days, which is 25.5 terabytes per year. Okay, and which is again converted to 5 years, nothing but we have to have our estimations, right? As I discussed in my previous video, we need to have a futuristic growth as well, 1 year, 2 year, 3 years, and up to 5 years at max, right? So 25.5 TB multiplied by 5, we get 127.5 TB, and approximately we are going to have 128 TB of storage that we need for our 5 years estimation. So based on this estimation, right, what we can do, we'll know what is the storage cost that we are going to pay to the cloud providers that we are going to decide, right, how much cost it is going to be, and based on this size we can decide which cloud provider we have to choose, and we can go for some discounts that they can offer, or some discussions you can have based on that, so that you can get some best price out of it. All right, so this is about storage. So once you have storage, next we'll have the bandwidth. So then what is the difference between storage and bandwidth here, right? So let us understand that. So storage is where in your DB you are going to store your URL details, the actual URL, and then TinyURL, your metadata, etc. But bandwidth is something to that system that you have stored. If I am hitting from my laptop to your system, it has to travel through the network, hit that system, and then get back the data to my browser. It requires some data to be transferred, right? So that is what we call it as bandwidth. Okay, if I have to show you, let's say I go to this LinkedIn, okay, LinkedIn, okay, and how you see it, you will see that if you click on inspect, okay, you will and go to the network, and okay, let's go to network. If you see, this size that is going to come with the network is nothing but, we say, is the size that is going to come. Okay, right now it is loading. Let's say I'll click on all, maybe. Yeah, I click on all. Yeah, see this is the size, right now it is 0 KB, 20 KB, etc. This is the bandwidth we call. But if your server is not going to handle that bandwidth, then obviously user is not going to have a pleasant experience, right? So for that, what we are going to do, so we have 116K reads, right? So where this number comes, estimated read, so user that are going to hit, so we have it here, estimated 116K. And with that, right, what is the size of each, okay, each URL? It's 500 bytes. We are not going to consider about metadata. We are going to once you hit the TinyURL, it will hit their application server, and it will expand it, and then it will return the data to us. You may not see the the larger or the actual original URL in your browser, but it is what going to hit the server and then give it to you. So 116k reads per second we have, and then each URL is 500 bytes, so it's going to be 15 MB megabytes per second. Okay, but if you see, there are something called megabytes per second. Okay, and we have megabits per second. Okay, so megabytes per second, which we use it for file transfer. Okay, Gbps, Mbps, we say bytes per second. But when it comes to the bandwidth, internet speed, right, we network, basically we call it as bits per second. If you if you go to again, I'm going to Google. Okay, I'll close this, and then if you see this speed test, okay, it's going to show you your speed in bits per second, Mbps, megabits per second, not bytes per second. Okay, it's, if you see the small b, it is nothing but bits. Okay, so hence I have to convert my megabytes per second to bits per second. Okay, if you see here, it is going to be Mbps. What is my download speed and what is my upload speed? It's going to be, okay, it is 187 megabits per second, not bytes per second. Okay, so coming back to my discussion here, so this bytes, right, I have to convert it to bits. How? Multiply by 8. 1 byte is having 1 bit, so it is going to be 464 Mbps megabits per second, and approximately I'm going to take 500 bits per second. Okay, and definitely for this bandwidth as well, we need to calculate the peak one. So 500 bits Mbps into 3, it's going to be 1 gigabits per second is going to be your bandwidth. If your system is not capable of handling this requirement, then your users are not going to have a pleasant experience, and your maybe the system might not respond properly to all the requests will drop in between, etc. All those issues will come when there is a spike in your system traffic. All right, next we have something called cache estimation. Okay, why do we need cache, by the way? Cache is something, a RAM, I would say. When you have a server or CDN network, each will have a RAM. Each cache is nothing but RAM. So for this, we have other systems like applications or softwares like Redis is one of the open source cache system that we have, right, which we have to use it. And when it comes to cache, we apply something called 80-20 rule. Okay, meaning you have 100 million users, okay, out of which 20 million users URLs are going to bring 80% of the traffic. Okay, that is the assumption. 80-20 rule, which is normally applied universal rule that applied everywhere, and 80% or 80 million of the users URLs are going to bring only 20% of the traffic. So for that, what we are going to do, this 20 million URLs are called as hot URL, we can say, those will be cached. Okay, so that if a user is hitting those URLs, will be served with a lower latency, maybe 2 milliseconds or 3 milliseconds, etc. Okay, and each URL, okay, is of 700 bytes, right, which we calculated in our storage estimations, right, and approximately it's going to be 14 GB, right, and then you never know, right, 20% is you cannot be hard or rule on that, right, so it might go 25 to 30% of the URL, hence we may have some buffer with it. It is to be you can have 15 to 20 GB of your cache estimation to be on the safer side. Okay, now next is DB estimation. We estimated about our cache and the bandwidth. Now database storage. We know that for 5 years our storage is going to be 128 terabytes. Okay, how do we know that? We calculated here. This is our storage estimation. In this estimation we come to know what is our storage going to be per day, per year, or 5 years, right? So we know that our storage is going to 120 TB, but we are not going to have this all 120 TB in one server, right? One server. We need to have proper distribution of data, so that if something goes wrong with some server, others will be able to serve it, right? So, and again, when we say 128 GB, right, so that is we are talking about the raw data, which is obviously database size has to be greater than the raw size data, because we might have database has their own techniques of securing the data from fraudulent attacks, or writing the corrupted data, etc. We might have something called write, hide, log, and etc. all other concepts which we'll discuss when we come to this database section later on. Okay, so hence the db size will be greater than the raw data. Okay, and we have, okay, now we know that we have ER of 128 TB of size that we need, and let's say we have one server which is equivalent to 2 TB. Servers is nothing but you can say your laptop. Okay, like that we might have multiple laptops of 2 TB of hard disk, and we connect each other to make it 128 TB, so that each data will be segregated in between those, right? So 128 TB, each server will have 2 TB. That means we need 64 servers to handle our data in 5 years down the line. Okay, may not be in the first year. Okay, that is our estimation that we have, and then accordingly we can estimate the cost, and then the business users can plan their system. Okay, and definitely we'll have a peak for this as well. Okay, we'll have replication factor 3, right? One server will be act as a primary, and thus 2 will act as a secondary. If anything happens, as we might know that, right, data will be in any data center, data will be stored in terms of racks. Okay, racks will be in the data center, data centers will be in zones, zones will be part of regions, regions will be a part of country, and country will be part of continents, etc., right? So accordingly the data will be replicated in multiple 3 places, so that if one right, if one replica goes, your users will be served from other replicas. All right, so that is the replication factor. So totally we will need 192 servers, and accordingly we have to plan for our cost as well. Okay, next we have something called CDN, content delivery networks. Okay, so let us assume that, so why content delivery network? Okay, so let us assume that as a user, okay, we are sitting in Bangalore. Okay, and we are hitting a server, okay, an application which is there in USA. Okay, so every time when you hit through your browser, okay, your let's say you hit through Chrome. Okay, if you are hitting the server in the USA, and if a request is coming back from USA, there is going to be a lag in the system. Basically the latency is going to be more. Okay, for that it's not required that we have to hit the main servers every time. Okay, for that what applications will do is, okay, if this is going to be the main application, okay, it is going to be divided into multiple content delivery networks. Okay, so what I'm going to do is, we have multiple content delivery networks. Okay, so what we are going to do, let's say in India I have one content delivery network, in Europe, EU, I'll have one content delivery network, and in Gulf region I'll have one content delivery system. Okay, multiple cities will have, multiple regions will have. Okay, so here I'll have, let's say I'll have one Bangalore, I'll have one Delhi, I'll have one in Kolkata. Okay, here I'll have maybe in London, Germany, and in Georgia, and in the Gulf region one I'll have in Qatar, one I will have in Dubai, and one I will have in, let's say, Bahrain. Okay, so if I'm hitting in Bangalore, my request will not go to USA, it will come from this content delivery network which is there in Bangalore. Okay, and there are also something called static content and the dynamic content. if it is static, like thumbnails or the images or etc., static website, right, it will, once you hit it from US server, right, for the first time it will hit the US server, and the next, and it will be stored in this content delivery network, and the next time onwards, whenever you hit that same URL, your request will go to this Bangalore content delivery server, and then it will return you. So the latency is going to be very, very less, and it is also very useful. It is against any security threats, like DDoS attack or etc. Okay, it will save. You don't have to go back to it won't hit this server. But when it comes to the dynamic content, right, it has to go through this server itself, and then it will be responded. Okay, so this is how an application will be decided. Okay, what is the content delivery servers that we have, networks that we have to set up. Okay, and then what should be the replication factor, and with this we will come up with what is the cost of running an application or running a system for the 1 year, 2 years and 5 years down the line, and accordingly we can plan our system. So this is about a the TinyURL capacity planning. Similarly, we can have this capacity planning for any system that we want to develop. It can be a online platform, it can be agentic system or a RAG system, AI system, or a big data system that you are going to develop. Each and every system will have to go through this to handle and perform better in coming years. All right, so I hope you are able to understand this capacity planning of use case of a TinyURL. We will come up with couple of more use cases, so that we will understand these things better. All right. So this thank you so much. If you have any questions, please feel free to comment it, like this, and share this video with your friends and family. If you want me to improve something, please do let me know in the comments, and I'll be happy to implement those. Thank you so much, guys. Take care and have a nice day. See you in the next video.